Good day, Ms. Saliha. We are Group 3, and our group consists of Benvinder, Hoh Kai Sheng, and myself. So the object we were given was a plastic, was a bottle, and based on the bottle we were given, it was supposed to have more height than the length and the width. So based on that, we had a discussion on how the object should look, and we decided that the 3D sketch is going to look like so. You can see on the left hand side. Then the interior, we decided that we were going to have two floors, the ground floor and the first floor. So the ground floor, you can see it at the center of the screen, and the first floor, you can see it at the bottom right of the screen. So we decided we were going to have two floors, and we are going to have a roof, which was supposed to be installed with solar panels. Next. We had three main objectives. The first one was to recycle plastic to create a house, because plastic, we wanted to make better use of plastic than it's currently being used, to make it more environmentally friendly. Also, we wanted to use solar panels to power our house because solar panels are renewable sources of energy, and we would also reduce the burden on fossil fuels to produce our electricity, ultimately protecting the environment. Lastly, we wanted to allow poor people to live in a comfortable and healthy environment by making houses that are made of plastic and running them with solar panels, which makes it much cheaper. Next slide. So this is our task distribution. First, once the project was decimated, we decided to have a meeting where we discussed our objectives and our scope. Once that was done, I took charge of putting it into words in our report. Hoh Kai Sheng was in charge of the background and background regarding plastics and how it's recycled and how we can make better use of plastics. Benvinder held the fort for the concept of a design and the origin of the idea. And we discussed as a group that we're going to have two floors, and we further finalized the layout plan and the exterior of our house. I took measures towards completing the hand drawings, and Benvinder and Hoh Kai Sheng were in charge of the AutoCAD models. Once we were done with all our hand drawings and our AutoCAD models, we finalized it into a report and put the required words into it. Now I'll pass it on to Hoh Kai Sheng to continue with the background.
Okay, so I'm Kai Sheng. So I'll be talking about the background. So okay, let's start. The financial crisis of 2008 emphasized the critical role of having a place to live and the ability to own a house. The crisis wiped over $16 trillion of the value of global financial assets, plunging much of the globe into a severe recession after 3 decades of unparalleled prosperity. So since then, owning a house is impossible. For example, millennials with a degree in Malaysia have an average salary range in between 2,001 ringgit to 2,500 ringgit, which makes owning a house out of the question. So therefore, we as a team is determined to design a house that is affordable, environmental friendly, and most importantly, comfortable. Okay. The idea behind our design is simple, and it came from a small village in Panama. Okay, a small country located between the Caribbean Sea and the North Pacific Ocean. Okay, the design is to create a house using used old plastic bottles. However, the concept of building a house with the main material being plastic bottles is not new. The structure of the house at Plastic Bottle Village are made from used plastic bottles. Steel rebars welded into the cage are used to construct the panels. The plastic bottles were then coated with concrete. So this made the house earthquake resistant. In Plastic Bottle Village, a 100 square foot house can use up to 16,000 plastic bottles. That is what the average person uses in their lifetime. It is also extremely affordable, starting at 19,000 ringgit per unit. So our team's goal is that our design will take off and inspire others to live a more sustainable life. Now it reaches the part where it makes the design of our house unique, because of our team didn't just copy the design and the structure and materials directly from Plastic Bottle Village in Panama. We improved it. This will be further explained by Ben now in the concept of design.
Okay, so now I'll be talking about the concept of our design. Our house is made of plastic bottles and strengthened with several other materials to keep it sturdy, and the construction of this house will be highly beneficial for the B40 community. Since plastic bottles will be used, this will be a perfect replacement for bricks. These plastic materials are clumped into cubes and are tightly held together by a wire mesh cage, which is then connected to a rebar steel cage. These cages are then stacked onto one another to make up for the walls of the house. All plastic materials that are recyclable can be collected and used for the construction of this house if they are in normal condition. The advantage of using plastic bottles are that the amount of plastic waste on the surface of the earth will be greatly reduced, water and land pollution will be reduced, this is a cheaper choice of material, and the ventilation of the house will be good. Next. Once the walls are up, lime plaster could be used to coat them rather than using cement. Lime plaster is one of the greenest materials in the construction industry due to its purity. The advantages are that lime plaster helps absorb and release moisture through the walls more easily compared to concrete walls. Besides that, there is lesser energy embodied within the lime plaster coated walls, making the house more cooling on hot days. Lime plaster also glows due to the double refraction of light, which makes it more attractive at night. Furthermore, lime plaster heals on its own by depositing as the water on it evaporates. Thus, we would not need to worry about any cracks. The lime plaster would also absorb carbon dioxide from the air, reducing the greenhouse effect by a great margin. Next. Instead of using concrete, timber, and steel as the material for the columns in the house, we would use bamboo. This is because bamboo has higher tensile strength compared to the materials mentioned earlier. Bamboo also grows rapidly after being cut, thus we can avoid global warming. Using bamboo is also a cheaper option compared to other materials as it can be obtained naturally from jungles. Furthermore, bamboo is also flexible and elastic. In the case of an earthquake, the house would be able to sway with the vibration, reducing damage to the house by a large scale. Next. Once we have completed the body of the house, we would then install a shingle roof made of recyclable materials such as plastic, wood fiber, and rubber. There are many advantages that come with this roof. They are ridiculously cheap and are durable as they have a lifespan of up to 50 years, eliminating the need to change them regularly. It will also reduce the amount of waste on the surface of the earth, reducing the level of pollution. Next. Finally, once the roofing system has been installed, we will then install solar panels onto the roof of the house. Once we have installed solar panels, we would not need to pay for electricity in the long run, and in fact, we would actually get paid by utility companies for any extra electricity generated. Using solar panels to generate electricity is also one of the most green and efficient methods to produce electricity compared to burning fossil fuels. They also need to be maintained twice a year at most, and if they turn out to be faulty within the first 10 years of its installation, they would be replaced at absolutely no cost. Now, Kai Sheng will present on his AutoCAD design.
Okay, now I'm going to briefly explain how I drew this 3D model of our house. Okay, firstly, I drew a rectangle with rounded corners and extrude it to 5 meters high. And to make the roof, I simply just make an ellipse cone and extrude it to 2.5 meters high. Okay, this results in a total height of the building being 7 meters high. Okay, to make the structure see-through, I've created a smaller rectangle with rounded corners and extrude it, then subtract it with the bigger one. Okay, for the windows, I did the same thing, which is create a rectangle and extrude it and subtract. It's actually very simple. So for the awning, I created a separate entity and just attach it based on the size of the window. Okay, now we move on to the roof. As you can see, it is flat here. I did that by making a cuboid outside of it and then subtract it by the cone. So finally, for the tip, where we are supposed to put solar panels, I did it by simply just adding a cone in it. So it's this design is fairly simple. Anyone can do it, like I think. Okay, this is the end of our presentation. Thank you for listening.